this one. The first one says, calculate the derivative of its function using the limit definition.
First, we have to get the first derivative with this formula. So with each term, we use this part, and then we subtract all the function, and we divide by h. Then we expand this term, and we multiply the 11 with their terms, so we get that. And then we multiply the 6 with her terms, and then we eliminate these terms because they are equal but with different sign. And then we know that all the terms that we have an h. So we factorize that and then eliminate the h because one are multiply and the other are divide. And then we substitute the limit of 0 in h. And then we get the formula with the first derivative, that is the velocity. Now we have to calculate the x and the y-intercept and the graph.
So to calculate the x-intercept, we have the formula, and then we have to equal the formula to 0, and then we have to have the common terms of the 6, that it's 1, 2, and 3, but it's plus minus 1, plus minus 2, plus minus 3. And then we have to do the synthetic division. With the synthetic division, each term that gets 0 from the result is going to be our points. So we have point A, that is 2, 0, B, 3, 0, and C, 1, 0. To get the y-intercept, we have the main formula again, and then we have to substitute each t, that is our term, from 0, and then we have to resolve it. So our result is minus 6. So our point is, the point is 0, minus 6.
Now we have to calculate the tangent line equation of the point P 0, 6. So to calculate the tangent line, we need to use this formula, but we don't have m, so we have to find the slope, that is m, and we have to substitute the points, and we get m is equal to 11, and now 11 we substitute in the formula, and we isolate, and we resolve, and the b is minus 6, so now we have the tangent.
The letter D says that we have to calculate the velocity of the particle after 2 seconds.
In order to calculate the velocity of the particle after 2 seconds, we have to substitute the 2 seconds in the function, and we resolve, and we obtain minus 1 minute per second, that is the velocity after 2 seconds.
Finally, we have to get the time when the particle is stopped in the interval of 0 to 2. We know that when the particle is stopped, the velocity is 0. So we equal the function to 0, and we know that the 3 is A, that the 12 is B, and the 11 is C. So we use the general formula. Then we substitute in the general formula, and we know that we get 2 results, x1 and x2. We get these 2 results, but we know that this is the result because the interval is 0 to 2, and this is 2.58 seconds, so we use this.